Okay, for question 10, let's take a look at the question. They say explain the following observation as fully as you can. Again, they didn't tell us what they want for our answers, so we have to know it ourselves. Okay, how do we do it? Well, we'll go step by step. They say sulfur forms the compounds SF4 and SF6, but compounds of oxygen OF4 and OF6 are not known. So firstly, if you see such questions, very simple. Look at the difference between the two comparisons. You have a sulfur atom versus an oxygen atom because the F4 is the same. So we just look at sulfur and oxygen. One is from period 3, O is from period 2. So based on this, you need to be very sharp to know that this question is definitely asking for expansion of octet configuration. So just a quick recap, our period 3 elements and onwards will have expansion of octet, but for period 2 there cannot be expansion of octet. Okay, so in order to be explicit, I would like to explain the diagram or again. So in this case, this part here, the diagrams, okay, not required in your answer, but I would just like to go through the thinking process again. Sulfur is group 6, fluorine is 7, 7, 7, 7, all single bonds. Okay, so all single bonds, and in this case, 4 single bonds. 1 single bond, 2 single bond, 3 single bond, 4 single bonds. So that means sulfur should be left with 1 lone pair of electrons. So in this case, total I have 2, 4, 6, 8, 10. 10 electrons, which is expanded octet. Okay. For sulfur, I have 6, then 7, 7, 7, 7, 7, all together 5 single bonds. So 6 single bonds. So just nice, I have 1, 2, 3, 4, 5, 6 single bonds. Okay, and 6 single bonds times 2, I have 12 electron, which is again more than 8 electron. Okay, so in this case, how do we explain? Well, this is actually just a very quick recap of your page 19 of your lecture notes. Everything is actually there, but just like to recap the explanation. So we need to mention that S belongs to period 3 and it has energetically accessible vacant 3d orbitals. Please take note of the keywords. You need to have energetically accessible orbitals and it must be vacant orbitals. Since S is in period 3, it will have 3d orbitals, and hence it can accommodate more than 8 electrons in the valence or outermost shell, okay, to form an expanded octet. Of course, hence SF4 and SF6 can be formed. So moving on, of course, we mentioned that O belongs to period 2, and of course period 2, we just stop at 2p. We does not even have d orbitals, so it's therefore unable to accommodate more than 8 electrons in the outermost shell. Okay, so both of these compounds will not be formed. It's just as simple as this. Okay, page 19. Okay, refer to it for a quick recap. Okay, for question 13, actually it is a rather logical question. Okay, so why is it logical? Let's take a look. They tell you that this small lizard can climb out a smooth glass window and it has millions of microscopic hairs on its toes, and each hair has thousands of pads on its teeth. And the result is that the molecules in the pads are extremely close to the glass surface on which the gecko is climbing. So what is the attraction between the gecko's toe pads and the glass surface? Well, if you look at the options, it is very obvious that the answer is van der Waals forces. Now, why is it obvious? If you look at all the other options, ionic bonds, it is so strong, okay, that in an ionic compound, okay, the melting point, let's say the melting point or boiling point is so high, it is like a few hundred, okay, it can be a few hundreds okay, or even thousands of degrees of Celsius. So how can it be, in this case, how can it be ionic bonding? Otherwise, how can your gecko move, okay? Correct not? Then in this case, covalent bond, also very strong, also require lots of energy to break. Okay, similarly, your coordinate bonds actually just means your dative bonds. Okay, and remember that dative bond, once formed, okay, it is just like a covalent bond. So in fact, it's just a covalent bond, which is again very strong. So in fact, ABC doesn't make sense. Only D makes sense because van der Waals forces are weak. They can be easily overcome.